Hello and welcome back to College Algebra, MAT 150. In this lecture, we will be discussing composing functions. So, brief recap. If you see something inside the parentheses of a function, that's what you plug into the formula. So, if you have f of x equals x squared minus 2x plus 1, and you see f of 1, what do? Well, you plug in 1 to the formula. So it says x squared, so 1 squared minus 2x, so minus 2 times 1 plus 1, right? So we're not going to simplify this, I'm just making a point. So if we saw f of 3r plus 4, what would we do? Well, we would take 3r plus 4 and we'd plug it in for x, so 3r plus 4 squared minus 2 times 3r plus 4 plus 1. Again, we're not going to simplify, we're just proving a point here. So what if we saw f of g of x? Well, what's inside f of x? G of x is. So what do we do with the g of x? We plug it in. So g of x squared, we don't know what g of x is, it's just some function, times 2 minus 2 times g of x. Actually, I'm going to stay consistent here. Plus 1. The only problem with this is that that's exactly what we had to do. So now, with that out of the way, what is composition? Well, between two functions. Well, we looked at addition, subtraction, multiplication, and division. Composition is another operation, one that we can do between functions. And the operation is given by a little circle, an open circle. So not filled in like a dot like we would for multiplication. So a lot of people confuse this for multiplication. It is not. And what it means is if you're looking at two functions and you do the operation of compose, that means that you plug this one on the right into the one on the left. So f of g means take g and plug it into f. Okay, the whole function. That's all that it means. And more specifically, if we read it, it says given two functions f and g such that for all values in the domain of g that become outputs g of x that are in the domain of f, the composition is then defined as we just talked about it. So it says such that for all values in the domain of g that become outputs g of x that are in the domain of f. That is a mouthful. And that deals with sort of the domain that we'll talk about. So we'll come back to this idea, but for right now, we're just going to bypass it and say just plug G in for F. All right. So what is F of G? Well, as we just saw, we take the one on the right and we plug it into the one on the left. So F of, and I'm going to put, instead of putting the two parentheses like you sometimes see, I'm going to put the bracket and then g of x. But what is g of x? Well, g is this formula here, 3x plus 2. So f of g of x is really f of 3x plus 2. And now we know exactly what we're plugging in. 3x plus 2. And we plug that into f. What is f? F is 2x squared. So 2x squared, but instead of x, we're going to plug in 3x plus 2. That's all that's going on. So how do we do this? Again, how do we simplify this? The order of operations still matters. So inside parentheses p, and then we do the exponent, so 2 to the second, and then you multiply by 2. So don't distribute the 2 first. So we still have 2 on the outside. And what's 3x plus 2 times 3x plus 2? Well, again, that's the definition, 3x plus 2 times 3x plus 2. You can FOIL it out, or multiply it out term by term. 3x times 3x is 9x squared. So I'm just doing that down here. So 9x squared, 3x times 2, that's 6x. Then 2 times 3x, and then 2 times 2, so plus 6x plus 4. And we're left with 2 times 9x squared plus 12x plus 4. So we just combine those. And then we just distribute the 2. That's on the outside, and we get 18x squared plus 24x plus 8, multiplying the 2 to each one of these terms. So what is f of g of x? After you plug in, so that means plug g into f, but g is 3x plus 2. That means we're plugging 3x plus 2 into f, which is 2x squared, so 3x plus 2 plugged in there. We then FOILed it out and then simplified and distributed the 2. All right? So f of g, that's what we got. But we could also do g of f. So in this case, again, the one on the left is sort of the outside function, and what we're plugging in is the one on the right, which is, in this case, f of x. But what was f of x? Well, f of x was the 2x squared. And what was g? G is 3x plus 2, so 3x plus 2. And we're just plugging in, so what's inside the parentheses is what we plug in, so we're just plugging in 2x squared here. And what we get here, 3 times 2x squared, again there's no exponent out here, outside the parentheses, so we just multiply straight away by 3 and we get 6x squared plus 2. And if you notice, g of f is very different from f of g. So f of g is not the same as g of f. In other words, this operation is not commutative. You can't switch the order and it'd be the same thing. All right, but what about f of f? We could also do this. We don't have to compose it with different functions. We could plug something we got out into the same function. It's actually pretty common in mathematics. So this means on the outside is f, because it's on the left, and what we're plugging in is on the inside is also f. And in this case, f is 2x squared, so we're plugging in 2x squared. What are we plugging it into? Well, into 2x squared. So 2x squared. So what are we plugging into it? 2x squared. So just like before, we do the exponents first. So 2 squared. So we still got 2 on the outside. So 2x squared is 2 squared and then x squared squared. So 2 squared is 4. And what is x squared squared? That's x to the 4th. And then now that we've done the exponent, we now multiply. So by 2, we get 8x to the 4th. And we get that. Similarly, for g composed with g, that's on the left is what goes on the outside, and what we're plugging in is what's on the right. So plugging in g of x into g of x. And g of x is 3x plus 2, so g of 3x plus 2. And what is g again? Well, it's just 3x plus 2 still. Plugging in 3x plus 2 into here. And then we distribute. So we start simplifying. So again, no exponents, so we can start doing this. 9x plus 6 plus 2. So then 6 plus 2 is 8. So 9x plus 8. So g of x is equal to 9x plus 8. As a formula, f of x is 8x squared, g of f is 6x squared plus 2, and f of g is 18x squared plus 24x plus 8. This concludes this lecture.